Okay, hello people. So in this video, I will try to go through the functionality that I wrote for the growing array, and this would be the continuation of the previous video that I recorded. So basically the whole idea is to write the growing array and measure the performance, like a custom growing array with custom allocation, and measure the performance against std vector and see the difference, how it behaves by using different functionality, for example, insert, erase, erase elements, pushing backward, pushing back, etc. And today in particular, I will try to explain how I implemented insert function and insert using range. So basically when you provide, I don't know whether you can see something, I might try to increase the font size. Hopefully it will be better. So yes, let me show you quickly the implementation. So here what we have is overloads for insert function, and as you can see we have the insert function, which takes a const iterator as a position as a first argument, and then the const object, right? Then the same but for r-value reference, and then const iterator with position, and then takes the size, not the size but the count of type size t, and then takes an actual object. And what it does, and I will later add the documentation and push the code on GitHub, and I will document like every single function, so it will be much more clear what is happening, right? But for now it's not necessary because it's in development. So what it does is inserts this amount of elements and essentially that many copies of object starting from position specified as a function argument. And we'll get shortly to the implementation, but I wanted to show you another function which takes an const iterator position, and then it takes an iterator first and then iterator last. And the reason why I why I had to put the implementation itself inside the class is because we have a different template parameter, and this is for iterators. And it is important that iterators, those point to a different growing array or a vector, and today in particular I will show you how to use SD vector and using this function insert all the elements into our growing array, right? And we will go through the code as well, but and I will try to simplify it a bit because it's a bit messy, but yeah. Okay, and let me quickly show you the insert function. So let's start from this one where we take, and probably the place has to be replaced with the position. I've tried to replace all of them, but okay. Okay, so let's take a look what I have. So we have const iterator, the position, and then we have an object, right? And I'm using like the helper function underscore insert, and I will rename it as well. I will put it to do now. Use shift function and position 1. And we'll talk about it later as well, what it does, because it is not implemented yet. But essentially, it calls the insert function, and the first line, what it does is we assert that the position is greater than begin and less than or equal to end iterator, and then we check whether we should grow. So basically says that, okay, if I add one more element into the current growing array, would I do I have enough capacity in order to fit, or do I have to reallocate the memory, like allocate a new buffer and then copy all the elements one by one? Or yes, using the memcopy. And in this case, I check, okay, should I grow? If yes, then I grow the array and reallocate the memory and copy all the elements, and it validates all the iterators, obviously. Auto, then I take like the iterator to an end, and this can be implemented differently as well. I will pull out into a separate function in order to simplify it, but basically we iterate over starting from the end to the position. Why from the end is because we will have to move, and let me show you. So let's assume this situation where we have, for example, this element, let's do -3, then this, and here we have an end iterator, right? And we trying to insert, for example, -4, and the position would be these. So this would be the position, right? The second element. So what would happen is that we insert -4 before -3. So the final array would be 234, then -4, then -3, then 78, obviously, right? And then the end iterator. What this function does is it starts from end, and it moves all the elements and leaves the empty space. So basically, after the function is invoked, the array, the underlying array would look like this. So I copy all of that, and so basically that's how it would look like. And here is our empty space where we will insert -4, right? So I iterate and I copy all the elements here one by one. And we can do it as well like this, so we don't... so we use the std function, right? That's all correct, and then it returns as an iterator, which basically the place where to insert a new element. In this case, it's this place, like the new place. And then we get the iterator back, and then we insert an element inside of a growing array, and then we like decrement the size by 1. Here, it's exactly the same, but we move the object because we passed it by our value. Yeah, that should be simple enough. And let me take a look at insert function. When we take the const iterator, the position, and then we take the count, and then we take the object. And essentially what it does is copies this amount of objects into the growing array. And what we do, we check whether position is greater than begin, less or equal than end. That's all great. Then we grow array if necessary. So we check whether, okay, what happens, does like size plus the count exceeds the capacity. If it does, then we have to grow array. So we get like the maximum out of it. The ML max is just a macro which returns the maximum number. And then, so this is not needed. This is not needed. Then we have auto, and it's a bit dangerous, but I couldn't figure out a better way how to do it. So we just do the const cast, and we get and we create a new iterator at, which points to the position, and then we use std distance. And what it does is basically computes the amount of elements between first and last iterators. And it can be positive if first is less than last, and it can be negative if first is greater than last. And in this situation, I check whether at plus count, which is essentially our position plus the number of elements that will be inserted. And if our position plus the number of elements that we are going to insert, it basically goes past the end iterator, thus the distance will return a negative value. What we have to do is we have to iterate through all the elements that are left, that are between and at, and move them to the position at plus count. Iterator plus count. So what we do here is we iterate over. So let me give you an example. I think it would be better like to see something visually. So let's imagine, okay, actually let's take this example, right? Right here. Let's take this example right here, and what we have is, okay, we have 234 minus 4 minus 3 and 78, right? And let's assume that we want, and this is the position. And this is the position, and count equals 4, for example, which means that we will insert objects here and in 2 more places after that. Thus, we would have to move, we would have to start at, so this is our at, and iterator, we would have to start at that position, iterate up until end, and swap the elements. So basically, because there are, and swap the elements, because here all the elements are 0 initialized, right? Because this is what our grow function guarantees, that when we reallocate the memory, all the members are 0 initialized. And basically we iterate over, so we have only 2 elements, right? And what we have to do is we do this and this. So those 2 elements will be here after this loop. Oops. And we obviously won't have no, actually. So here we have an AND iterator. So as you can see, we freed like the space for 4 elements here, and that's exactly we will insert all of those objects. So we iterate in this loop. We iterate starting from 0 to the count, and then we use iterator at or our position, but since the position is const iterator, we cannot use it, right? We cannot write to the const iterator, but what we can do instead is write to a regular iterator. And we write the copies of that object, and we decrement the size. So yeah, this is basically what happens in this loop right here. And we have an else statement. And else statement is for the case when position plus the count gives us a positive value. The distance gives us positive value, which means at plus count will be less than end iterator. So it will land somewhere between the begin and end. And let me give you an example. For example, if count equals 4, right, and this is our position, then by unless, for example, takes 3, right? So for simplicity, then position plus 3, position plus 3 is the distance, position plus 3 and end would be greater than 0, right? And in particular, it would be 1, 2, 3. So it will be one element. And in that case, what we would have to do is we have to start from the last element and iterate up until the position inclusively and move all the elements to the newly allocated place. So what will happen is this. Okay, so to 100th, this, and what will happen is that let me see. So our position is here, and which means, and we want to insert 3 elements, right? So we take 78, and here we have end. So we say, okay, 78, we free this, then minus 3, okay, great. We free this slot, and then minus 4, okay, great. We free this slot, right? And then 232, 34, sorry, we free this slot. This will disappear. This will disappear, right? And we will have memory for 3 new elements to be inserted, right? So what we do, and let's imagine that our object is equal to 11. In that case, what would happen is 11, 11, and 11. Yeah, so that is basically what will happen in this situation. Yeah, okay, and I was thinking about, let me adjust the editor a little bit. I was thinking about pulling that out in the separate function, like in the separate helper function like shift, which basically takes the, let me show you, because I'm duplicating the code, so it's not great. And let me try to compile. Object undeclared identify. Okay, I forgot the angle brace. Const iterator undefined. Okay, makes sense because I would have to prefix the actual function. Is that? Yeah, should work. And exactly what I want to do is pull all of these except the place where I copy the elements, because that would be different into these function. Okay. Okay. and then we would have to return the iterator at. So this is our shift function, and now what we could do is we check actually whether, yes we do, okay. What we could do is say auto at shift, and then we specify the position, and then we specify the count, right? And then we remove all of these except the place where we actually copy the elements. This is what have to stay, because it will be different for insert with first and last iterators, this one. And that is the reason actually why I want to pull it out into separate functions, because I had code duplication here. And that's what I want to avoid, right? So I have a shift function which works correctly. Let me try to compile and see whether I have any errors or not. And I will get to the testing code soon, but what I can do here is replace it with shift as well. And hopefully you understand what shift does. It just moves position, and auto count equals std distance first last, and I would have to do it like this most likely to get the absolute value. And then this is not necessary. We can remove it, and the function is simplified quite a lot, so that's great. And at the end we update the count. Okay. Okay, great. So let's compile and see. And here I have some testing code. Let me move it a bit, because I'm pretty sure that there is my head somewhere, and which doesn't allow you to see properly. So let's comment out this code for now. Just let's introduce like a simple and if block. Oops, what happened? Okay. So we will avoid that for now, and let's focus on this code, like inserting. And here I have different implementations. For example, let's insert 3 elements into the array. And let me debug. Okay. Okay. Oops. That's not what I expected. That's not what I expected. What we can do is, that is strange. Why did it fail? Because we haven't even gotten to that place. Okay, so let's double check. Okay. Oh, maybe it's because I'm using swap. I've replaced it with swap. Okay, let's step inside and see what it does. Yeah, this is initialization for the string itself. So that worked fine. Okay, but the second one didn't. Okay, so we move it and then we break, and then we return at, and then we insert the element. No, that's not correct, because what should happen? Okay, so here we shouldn't break. Here we shouldn't break because, and then we won't increment at, then we won't decrement at pointer, right? Okay, so let's see what happens now. Yes, that's correct. Let me take a look at iterator. What does it equal to? So currently it points to that place. Which is not correct, because it should return the iterator that we are going to insert a new element to. And here is the position. And now if we step back, we have our object, which has to be inserted into the here, but because we didn't decrement our add iterator, we just override the value. Okay, I see. And that is kind of a problem, because this is not how it's supposed to work. So what we can do instead is, if at equals position and the position equals begin, at equals end, doesn't equal to begin, I would assume that's alright to have it here. Because if we assign at to end, and if, for example, we specify that the position is equal to begin, right, so we want to insert before the first element, then at doesn't equal to begin, we make a step, then at equals to begin. And this is actually not needed at all. We don't need that. And we can do minus, no. It's actually might be a bit tricky, but we can even do it like this. And assume that in this, when we access this at, it will be already decremented, right? But yeah, I mean, I wouldn't do that because it's not safe, and I don't know the precedence rules that well. So the at equals to begin in this situation, and we just break, right? Okay, let's try. Yep, and we have gotten to our place, and let me take a look at the output, what we have here. So you see, this is the new element that we have inserted. So we had the S, which contained only one element. Okay, so we have maybe 15-20 minutes more, so I have to speed up a bit. So then we inserted the before begin new element, and then we inserted an element at the end and then in the middle, and we have like 4 elements in total. And then we get to the place where we involve our insert procedure, and let me put a breakpoint there here. So we don't grow because I assume we have enough capacity, and we trying to insert 3 elements of copy into the end of the buffer. So what we do is we compute the distance, and we see that the distance is negative. So we move all the elements. Oh, but we don't have to move because the iterator is equal to end, right? So we are already insert into end, so we don't have to move any elements because we insert it after the end of the buffer, which is great, simplifies. And then we iterate through the count and copy all the elements, and as you can see, copy inserted here, copy inserted here, and copy inserted here as well. And then we increase the size. And then we display the buffer, and as you can see, we have a before begin in the middle, newly inserted string at the end, and then we have copy 1, copy, and 1 more copy, which is correct. Then we do another insertion, and we step inside this function, but this time we start inserting elements from the begin, and we're trying to insert 4 elements, right? So in this case, we would have to move all the elements, and the distance is positive. And see what happens, how we move the elements. So the copy went here. This copy will go right below it, and we move elements slowly just by invoking copy assignment operator. And you see we emptied like the space exactly for 4 elements to be inserted. And now we can go to this function, and we can insert all of those elements. So copies, 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 etc. And then that will invoke the display function. And as you can see, we inserted exactly 4 elements here before the rest of the elements that we already had in our growing array, which is correct, which is exactly what we want. And yeah, in this situation, then we're trying to insert like somewhere in the middle. I will go quickly through the code, and we inserted 2 elements in the middle, as you can see, and then we insert at the end, but 2 positions to the left, and then we're trying to insert 5 elements. And as you might notice, here is the resulting buffer. So we have like 1, 2, 3, 4, 5 elements, and then we have 2 copies at the end, which is correct. And then let me uncomment out this code, because what I do here is I create like a vector, and then I specify, okay, how many elements I want to push. I push all of those elements into vector, and then I'm saying that, okay, this is my array, growing array. Please insert all of those elements starting from begin and iterating over, starting from begin, but the elements are actually located inside the vector, external vector, not this growing array. And then I print the size, and then I display the underlying growing array, right? So let's step through it. Let's go through it step by step and inspect the code. This is our previous breakpoints, and let me actually get to the point where we invoke this function. Okay, so here we are. Yeah, we compute those iterators, but what I want is to hit this breakpoint. And again, we compute the count. Count is 5 elements, because this is the length of the vector. And then we do the shift. We move all the elements that we had. You'd have to iterate over all of them and just move the elements one by one. That's great. And then we return the at iterator, which means, okay, where to start inserting the elements. And then we say that, okay, iterator, let's iterate through first and last element. So we say that, okay, we have an iterator which is equal to first, iterator doesn't equal to last, and then copy all those elements starting from at location. And as you can see, I copied the first string, then I copied the second, third, fourth, and fifth strings. And then I'm printing the underline array right here. It's quite big, but as you can see, hopefully we have the first element, the second element, the third element, and fourth and fifth elements inserted successfully, right? Yeah, that is correct. Let me remove all of that. Okay, and I would have to rework this function, and maybe I can take a look at this now in order to not to use insert, but rather use shift. Let's see what happens if I call. Okay, what happens if instead of calling underscore insert, I call shift position 1. Maybe it's already implemented. I would have to just try. Okay. So let's see, we compute the distance, and the distance is negative, which is alright. So we start from, okay, we don't move any elements. No, that's not correct, because we just overwriting the string. It's not correct. So let me go through it again and see what holds us from receiving the what we want. So if the count is equal to 1, we shouldn't grow, definitely. And then add plus count. Add plus count and end. So the difference is negative, right? So it's probably -1. So we start from at up until end. I would expect falling back to this solution. At -1. And then we copy, right? What if I specify 2 here instead. Would it work? I mean, it should, right? Let's see. It's a bit unclear what's happening, but I just want to test whether the functionality is alright. Now, okay, now. I was hoping to get to this point, but okay. Yeah, I would have to modify it a bit in order to use shift here as well. So let's see, we specify the position, and the position would be equal to position plus count. Okay, so we specified the begin iterator. So the add iterator is my first element, and my first element is the only element that we have. And then we compute the distance. And the distance is obviously so I don't understand why we don't step here. Because the add iterator points to my first element, right? My first element, but the AND iterator we just don't pass the condition. Okay, the iterator is not defined. Come on. Yeah, so they point to the first. Okay, but for some reason AND is incorrect. Wow. How do we retrieve AND? And data size. M size. Yeah, that should be all right. that returns this size. Okay, that is strange. It is strange because the end iterator and the begin iterator point to the same memory location. They literally have the same address. No, they don't. No, wait a second. So they have the same address. The size equals to 0 for some reason, but we have one element. Okay. So why does it equal to 0? So here we erase the begin. I would imagine that something bad is happening here inside the erase function. Yep. So now they are different. Begin and end, they are different, right? And we erase the element. So the size is equal to 0, which means they're empty. Okay. Yeah, this is not correct. Yeah, it shouldn't be like this. When we erase an element, it should be like this, right? Okay, so when we have an empty array, begin and end, they point to the same location. Yes, that makes sense. When we have an empty array, they point to the same location. Okay. And that's why we override the string. Okay, yeah, that's correct. Let's step inside and inspect one more time. So in this situation, since the array is empty, the begin and end, they point to the same memory location, right? We have enough capacity. We compute the distance plus count. And in this case, the count 1, but the at iterator is equal to begin iterator. Okay, so we step here. Okay, yeah, we cannot move because Yeah, I see. Wait a second. But on an empty array, we don't have to do anything. We don't have to do anything. Let me comment it out and see what happens. Yes, that's the newly inserted string, which is all right. And then we have one more, a couple more insert statements. And here we're trying to insert in the begin positions. We do this, and then yes, we swap. We put it in the first place, and then okay, great. And this is when we inserted the and. So we don't need that, and we don't need that as well. So we can successfully get rid of those functions and these function as well. Okay, so we have succeeded, and this is exactly our array, right? 5 elements with indices, middle, then 5 elements with copy, and the length is 23, which is exactly what it's supposed to be. Okay, one last function from the pile. So this is not needed. We can remove it, and we left only with shift function. Okay, so I will be finishing, I guess, for today, and implement insert functionality. I think we've done it, right? Yeah, we've done it today, which is always great. Overload assignment operator, not sure that is necessary, so the only thing which is left is this and the in place functionality, and I think I will put it into a separate session because I don't want to keep the session too long. So hopefully that was helpful, and yeah, see you in the next video. Take care.